You're alive.
Awesome. Hey everyone, thank you so much for joining us here on a beautiful Friday afternoon here actually, or wherever you may happen to be joining us from. My name is Marty. I'm a senior developer with Steed Games. We're a game studio and consultancy based in Sydney, Australia. And today we're going to talk about Git, which for experienced game developers, hopefully you've heard of it. If you haven't, awesome. Or if you're potentially studying or a junior or someone newer to the industry, hopefully this will be something interesting and valuable for you as well. So just to start, in the spirit of reconciliation, Noble Steed Games acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples here today. Alright, so let's get stuck straight into it. You'd think normally we'd start with a slide of like, what is Git for a talk called Git 101. We're just going to start actually with who is this presentation for, just to sort of set some expectations. Um, this talk is basically for anyone who works on the game team. And by that, we're not just referring to maybe developers or software engineers. Git is a very valuable tool that can be used across your entire team. So hopefully what we go over today will be just as valuable for artists, marketing team members, QA, testing, pretty much everyone across the entire game development team. Um, would find value understanding Git and how to use it themselves to work with any projects that you're currently using. Um, this particular presentation is aimed more at people who haven't used Git or any form of source control before. The example I give there, if you understand the difference between merging and rebasing, this talk probably isn't for you. Having said that, you're obviously more than welcome to hang around if you like. Hopefully everyone doesn't jump out of YouTube now as we're talking. But yeah, if you do have any more advanced questions on Git, ways to use source control and stuff like that for specific projects, then yeah, absolutely jump on our Discord. I believe Anne will throw the link in the live chat for YouTube as well. Because yeah, obviously more than happy to chat about it a bit further. Or if you do find this talk helpful and you would like us to maybe do, say, I guess Git 102, yeah, definitely let us know on our socials, and we can look at doing that. So we'll start with just some basic concepts, um, which is basically what is, to start off with, we'll go, what is version control? In a nutshell, version control is something very similar to what a lot of people are used to if you've used, say, Google Drive, or if you've used maybe like, Microsoft Word and you've gotten really used to, having an undo and a redo button. It's basically a way of working with a project, but it basically will allow you to track changes as things change throughout. So not only can you see what has changed at any particular point in the history of a project, you can also see who made those changes at the same time. So it's a very powerful tool. If you're ever stuck going, oh, this a certain thing has changed and we're trying to figure out why that may have happened, you can actually go back and look at exactly who made that change, when that change was made, and any comments that person may have left explaining why they actually made the change that they did. Or that might refer to like a Jira ticket or something like that, however you're tracking tasks within the project. It's also a very handy tool for collaboration on a project. Um, if you're, I mean, even if you're a solo developer, you might just have your project just locally stored on your computer. But if you're working with part of a larger team, it's obviously really important that everyone is able to see the latest version of the project as things are changing and moving around. And have a system that's basically designed to take all the changes that different team members might be contributing to a project and be able to pull them all together into one centralized source of truth. One thing I'll just quickly point out, I didn't actually write it on the slide here. Version control is not a backup. I would still recommend, even if you are using something like, say, GitHub or GitLab to store like a server repository for your project, you probably still want to look at some other form of backups there as well, especially if you have other files related to a project, like source art files, documentation, those sort of things as well. But yeah, definitely a very handy collaboration tool. So what is Git specifically? Git is a version control tool. It was developed in 2005 by Linus Torvalds, the creator of Linux. Basically as a way for for collaboration and managing larger projects. Git doesn't actually stand for, from the very first README file, from the very first commit of Git, yes, Git is stored in Git. Git can mean anything, apparently, depending on your mood. At various points through a project, you'll hear it referred to as many different things. But yeah, Git doesn't actually stand for anything in particular. It is one of the more popular sort of version control systems or source control systems in use today, both in game development and in just general software development as well. There are plenty of other options out there. We're going to stick just focusing specifically on Git for the purposes of this talk, because like I said, especially for Unity developers, generally you'll find this is a pretty common system that gets used in a lot of studios. Really good thing about Git, it's completely free open source, and also Git LFS, which we'll get to in a bit, is also free open source as well. So very handy there. Why Git, I guess, is we sort of touched on that a little bit, like the sort of reasons why you would use source control in general. Git obviously being a free open source version of source control is really handy for that. So yeah, it does things such as it lets you track code changes, track who made those changes, and collaboration. One little point that I've sort of added at the bottom there too, where Git is really great for teams of any size or even just solo developers. Even if you are just a solo dev working on a project by yourself, being able to easily maintain versions of that project between, say, a desktop and a laptop computer is a really handy thing that Git basically just gives you out of the box. But also just having that ability to see changes that you've made, revert changes, go back to earlier states of the project. If you're working maybe on a launched game or a live title, being able to say have a commit which is set at the point where your game was built and submitted to like the App Store or wherever the game happens to be, but then still be able to go on and do work beyond that. But then, being able to go back to that and that release commit and make, patching and do updates there as well can be really powerful as well. Or even if you're just, maybe your designers are asking for a few different potential ways that a feature could be implemented, being able to say do that without, do those separately and be able to give them the option of going in and actually having a look at how those actually play out, again, is a really powerful tool. And again, is one of the really powerful reasons why it's important for everyone on a game development team to at least understand the fundamentals of how to use Git, which is obviously what we're hoping to cover today. Hey, Drew, good to see you, mate. All right. So, in the interest of keeping things as simple as possible, and again, keeping in mind that this presentation talk, I guess, is aimed generally at the more wide development team and trying to keep things relatively simple. We're going to focus on using Git through a graphical user interface. Obviously, everything that we show here can be done through command line tools or just working through a command line as well, depending on who you are. Some people prefer one or the other. I quite like just using a GUI where possible. In particular, the GUI that we're going to recommend and we're going to use for today is called Fork. Fork, I believe it has a free trial version, and it's relatively cheap to actually buy a license for personal use. So it's quite a good little option out there, but quite powerful. It's actually my preferred GUI of choice. Some of the other ones that you'll see out there will be things such as Visual Studio Code does have some plugins to do source control in Git. Rider, same as that, has that as well. SourceTree is a free option that does that, and GitKraken. GitKraken's generally not as good if you're working with larger projects or more complicated projects, but if you have something just a bit more simple, it has quite a nice sort of user interface and sort of very nice UX work there they've done. Cool. All right, so let's start diving into some Git stuff. So we're going to start just with some terminology. Basically, the idea is we're going to quickly smash through all this, get this out of the way nice and quick, and then I'm going to jump over into Unity and Fork, and we're going to do basically some hands-on demo stuff for the rest of this talk, which hopefully will be useful. Oh, cool. I'm not the only person that likes Fork there. Awesome. Yeah, Forks are really cool. SourceTree, though, is a brilliant option, especially considering the price. So yeah, SourceTree is quite popular there as well. So going through some terminology, what is Git? As we said, Git is a version control system. What is Git LFS? We'll get to that in a later slide, but in a nutshell, it is an extension for Git that basically helps it support large files and binary files, which, because Git was obviously designed originally to work with source code, it doesn't handle those as well. It can slow down a repository quite drastically. So LFS is quite good, and for most game developers, it's something you generally should just have enabled in most repos that you're working in. Repo or repository is basically a folder stored locally on your machine, or can be stored remote. So if you're hosting on, say, GitHub, GitLab, Azure DevOps, stuff like that, you'd have it stored there as well, which will contain all tracked changes to a project. You'll see what I mean about that a little bit later on. But one of the reasons why Git is so efficient is it's only ever tracking anything that changes as a project sort of progresses, which is quite handy. The term clone is basically a command that copies a remote repository to your local machine. So generally speaking, if someone say had a game they were working on and you were joining that team, probably one of the first things you would do is you would clone their existing repo, which basically just means you're downloading it onto your local machine. But by doing it through a Git client or doing it through Git, it's going to set it up and track it and basically do all the behind the scenes stuff automatically for you. Staging and committing are two terms that you'll hear quite a bit when you're talking about using source control. Staging is basically the first step of taking the changes that you've made and committing it to your repository. So basically when you stage a file, you're basically telling Git, hey, this is a file that I have made changes to, so keep an eye on this one for me. And then when you actually committing will then take all the files that you have staged and will basically group them all together into what's called a commit. And we'll basically go, hey, this is a collection of changes that we've made. Within that will be all the individual files that you've staged. And then you'll see as the project sort of goes along, you'll have a collection or a list of commits that basically will show you all the things that are happening as you go. Local or remote. So the important thing just to keep in mind with Git, so you can have a local instance of a Git repository on your, say, local development machine, or maybe your desktop or laptop or stuff like that. And you can also have a remote repo as well. Generally speaking, for most say indie devs, if they're working with a remote repo, it's most likely going to be something that's stored through GitHub, GitLab, any of the sort of Bitbucket, any of the sort of popular cloud-based solutions. When you have a remote repository, most Git clients by default will refer to that as the origin, as in this is where the project started, sort of thing, and we'll go from there. A couple of terms just to sort of make sure we do some clarification on these, being push, pull, and fetch. So if you push, you are telling your local version of Git to take any changes you've made and push them or send them to the remote repository that you're working with. Pull being the opposite of that. A pull command is basically saying, hey, any changes which have been made on the remote repository, I want you to grab and apply them to my local repository. Generally, will be working within a specific branch, but we'll get to branching stuff a little bit later on. Fetch, slightly different command to pull. A fetch command is basically saying, hey, I want to know what's changed on the remote repository, so I want to look at it and see all the changes, but don't actually make any changes locally. So quite often, if say for example you've come back after a week of holidays, you might do a fetch command so you can see all the changes that have happened on a repository, and then say for example you've realized that there's been a bunch of commits on the main branch between when you went away and now, then you would probably do a pull command to bring your local branch up to date with the remote one. Most I believe Git by default, when you do a pull, will do a fetch command, but there is some GUIs and there is like a command line thing, I can't remember what the actual command is, where it won't actually do that. It will still just pull whatever you can see. If anyone knows what that command is off the top of your head, just throw it in chat, but yeah, just be aware of that. So generally just do a fetch first and then do a pull. Will stop you getting into any trouble. There's a couple of special files that we can work with when we're using Git. Probably the most important one of those is called a git ignore file. Git ignore basically is a file that tells Git, hey, we've got some files that we want to handle them differently in some way. The idea basically being that if you actually look within like using Unity as an example, if you actually look within like a Unity project folder, there's actually a lot of files there that are created locally and will get recreated whenever you open that project within like the Unity editor itself. So to save space and to save time and to save bandwidth, instead of storing literally every single file that you would have within a project in your remote repository, all we actually need to store are the files that won't get recreated if we were to say clone that remote repo to a new machine. So a Git ignore file is basically a way to tell Git which files you want it to be tracking and which files to ignore, hence the name. Important to keep in mind, so a Git ignore file is basically a .gitignore file, is like the file name. Depending on your settings on both Mac and Windows, sometimes that file will be hidden. So just be aware of that. On Windows, just need to go into like make sure you're viewing like hidden files and folders sometimes. There's a similar command on Mac as well. For Git ignore, you can have both a global Git ignore, which is set up basically to apply to any local repo being tracked by Git on your machine, or you can set them up on like a per project basis. You just generally will drop a Git ignore file in the root directory of your like Unity project. Now, having said that, generally speaking, you'll find you'll have much better luck if you just have a individual git ignore file for in each project folder. If you start trying to set global ones, you'll run into some weird edge case issues where there might be things that you want to ignore in one project, not another, and just things like that can go a little bit weird. A git ignore file, when you actually, so it basically will start working when you commit it to the repo. So we try to set up at the very start of the project. Otherwise, you're going to end up with a bunch of stuff which is tracked, which you may not want tracked, but we'll show that in the demo. For the purpose of the demo, we're going to use just gitignore.io, which is a super awesome website that basically can generate gitignore files for you based on whether you're working in Unity, Unreal, Godot, or more traditional like web development, stuff like that as well. So that link's just there as well. We mentioned before Git LFS. So as I said, LFS is a extension designed to handle large and binary files. So Git by default is actually pretty bad at knowing what to do with these. Having a lot of large files within a repository can actually slow it down quite drastically. So Git LFS basically is a way for us to still track when those files are changed within our repository, but the actual data, the actual file itself, we're going to just store it somewhere else in somewhere more appropriate for those sort of files, which is generally depending on where you're actually hosting LFS. It's usually just very much like just a like an S3 bucket or something like that. But yeah, the idea is basically we're just going to store these files just off somewhere else outside of the repository. But Git LFS will actually maintain references to those files for us. It will still track changes. So basically, it allows us to still work with the files as if they were in the repository without slowing down the repo. So again, for game developers specifically, a very important thing to generally try to have on all your repos. And again, it's one of those things that we'll generally just set up as part of the first steps of setting up a new repository. And once it's there, you're pretty much good to go. Important to note that different cloud-based Git providers, so again, GitHub, GitLab, stuff like that, will have different amounts of LFS storage depending on the account that you have. And I believe like GitHub, for example, actually allows you to buy like data packs to have more storage there available for them. But even then, on like personal like accounts, most of them I believe will still give you at least like a gig of storage on LFS. So it should still be something you're looking to use, again, even for small personal projects and stuff like that. In the same way that we have a .gitignore file, we also have a .gitAttributes file. So the Git attributes file is basically a way of telling Git LFS what to do with certain files, which files it should be tracking. We also use it for some merge related stuff as well, which we'll come back to a bit later on. And we'll show an example of that in there as well. Awesome. So that's enough of me just talking, staring at Google Slides. So what I actually want to do for the main part of today is we're actually going to go in, we're going to set up a Unity project. We're going to actually set it up in a repository. We're going to make some changes. We're going to make some commits, make some branches, all that good stuff. We're going to show what happens when you have merge conflicts. So what can happen if you have multiple people working on the same thing at the same time. We're going to look at some ways on how to actually resolve those conflicts as well. Hopefully we can get that all working. And yeah, and obviously if you have any questions as we sort of go, obviously feel free to throw them in the chat and we'll go through all those as we're going along. Alright, so what we have for our demo today is I've just grabbed a demo like asset from Unity. This one is, I'll grab the README file so I've got it on screen. Oh, and you might be able to throw the link in the chat for me. This is just their 2D sample project. It's freely available through the Unity asset store, which is pretty cool. I'll just quickly run it here so we can see here. It's got a 2D character controller, runs around. We can jump in the air, stuff like that. So nice and easy. And for that, let me just go find the folder. So, and this is the folder just here for that particular project. So literally all we've done is created a new project, imported the asset. I had to update some of the packages for it just to get it to work with this version of Unity, but outside of that, literally nothing else has been done at this stage. We can tell that this folder on my local machine isn't currently being tracked and isn't a Git repository because it doesn't have a .git folder. So it's a really easy way just to know that. But we've just started working on this project. We're pretty happy with it so far, but we want to actually, commit it to a repository so we can track our changes and maybe, have other people collaborate and work with us on that. So let's go through what we would do to actually do that. So to start with, we would jump into Fork. Fork has really awesome documentation on how to download and install it, so I'm not going to bother going through that here. If you also, both the Git and the Git LFS website have full instruction documentation on how to download them as well. Fork will come with a built-in instance of Git, which will be this one just here. Generally speaking, I usually recommend to people to download Git and Git LFS themselves, which is what I've got here, which is the one that I personally use. The main benefit of doing that is if you do change any settings on your locally installed Git instance, if you do happen to use multiple, say, Git's GUI, so if you are moving, say, back and forth between fork, source tree, stuff like that. Again, this is probably only things that happen to us because we work in the consulting field. Or if you want to do some command line stuff, this is just a safer way to make sure that you're working with the same instance of Git. So just, yeah, good little tip there. But yeah, so let's go through what we need to do. So we're just going to go File, and we're going to tell it to initialize a new repository. We're going to point that at the Git demo folder just here. So just the root folder of our project, and done. Awesome. Hope you've all enjoyed the talk. Okay, no, okay. There's a bit more to do than that. But the important thing here to note, if I go back and have a look at our folder, we now have a hidden, you can see it's a hidden folder, but we have a .git folder here. In terms of what everything in here actually does and what it is, don't worry too much about it. That's definitely out of scope for a Git 101 talk. The important thing to note, though, is that basically we now have a local repository looking at this particular project. But we can see here, if we look at the history of the project, that there's nothing there. If we have a look up the top here in terms of local changes, we can actually see that every single thing that is in this folder, Git has gone, hey, I can see this, I've got no record of it before, so it must be new. And it has gone through and found 31,960 files which have changed. Now, that is a lot of files, and we can actually have a look. If we go somewhere like here, for example, we'll see there's a bunch of stuff here that we generally won't actually need to store in the repository because they're going to be files which either only are used by ourselves locally. For example, the .idea folder, I use Rider as my IDE of choice. So this basically is local settings for that. So not really needed for other people to see those files. Or a lot of these files are ones that could be recreated by Unity itself just when we actually open the project. So as we said before, we've obviously got some tools to help clean this up a little bit for us. So I'm going to go in here and I'm going to grab our git ignore and our git attributes file. And we're just going to paste these across into here. Both of these files I'm going to link in our Discord as well. So if you'd like to join our Discord, you'll find them there. They're pretty straightforward. So like I said, the git ignore file that we use as a template is just the one that you'll find from gitignore.io. And we just add one line in there just to ignore those JetBrains of Rider folders there as well. But you can see here, like the sort of things it's going to ignore. It's going to ignore, user pref, so things which are stored locally. The actual, CSproj and UnityProj files, or the solution file. It's going to ignore certain kinds of debugging data, which generally you won't need to commit to source control. That's just things you'll use for like local testing. And all the sort of build artifacts and files that Unity will generate in the process of working on a project. We're just going to ignore those if we're not needed. So the library folder, obj, builds, stuff like that. So we've pasted them across here. Oh, I'll show the Git attributes as well. So this is the one that we use, which is basically telling Git, hey, there's a bunch of different files that we want to, instead of tracking them normally, we want to track them with LFS. So it's images, audio files, videos, 3D files, stuff like that. We do some stuff with like terrain files in there as well. And there's also a bunch that we tell Unity specifically, hey, we want you to handle any merge issues with these using Unity's YAML tool. We'll get to that a little bit later on when we look at how to resolve merge conflicts. But yeah, we've basically got a lot of stuff just sort of set up by default in here as well, which is pretty handy. All right, so if we jump back now and have a look at fork, we can actually see we've just dropped from 31,000 files down to 700, which is really nice. The other thing we want to do, because we've just created this as a brand new repository, we actually want to go into Git LFS and tell it to just initialize Git LFS, which is basically just telling Git, hey, it runs the command like Git LFS install, and it basically says, hey, like initialize this as an LFS repository. So nice and easy. So what does that actually mean for us? So we can still see there's still all the important files within the project are still being tracked by Git. We can still go in here. We actually can see literally everything that has changed. In this case, everything's going to come up just fully green because as far as it's concerned, everything's brand new. So we have to track the whole thing. But we can also see as well, if we look at say like a WAV file, which in our Git attributes, specifically audio WAV, we've told it to track it as LFS. We can actually see here that it's actually created it as an LFS reference here, which is really handy. The meta files still save as text because they're fine. But yeah, so this basically is already set up, ready to go to work with LFS. And we're now only going to track the files that we actually need to track for someone else to be able to pull this project in and work with it, which is cool. Important thing with using Git is make sure that whatever you put for your commit subjects and descriptions, they should be descriptive. They should be helpful for someone else to look at and see what's going on. So we're going to say starting new project with Unity 2D assets. Like that. Now, what we haven't done yet, so all these files are currently unstaged. We need to actually tell Git, or in this case tell fork, which of these files we want to actually commit at this time. Because what we could do here, say for example, we'd made some changes to maybe some audio files, but we'd also made some changes to some character files. In this particular commit, we might choose only to commit the character changes, and then we'll commit the audio ones in a separate commit, which again will make it much easier if down the road someone needs to go back and try to see why certain files were changed. In this particular instance, for like initializing a repo for a first commit, I wouldn't worry about this. I would just commit the whole thing at once. But we could always just go like say grab the character folder here and tell it to stage just that folder. It's going to grab everything under that folder as well, and we could actually just stage that separately. And you can see all the other files are still just unstaged at the moment. For the purpose of this, I'm just going to basically hit the two little down arrows here, which will just stage everything. So nice and easy. And we are going to commit. So if we go back here, now we can actually see that Git has automatically set up a new branch for us. So Git works with a branching structure, which basically means that as you commit things, it will basically go along the branch that you currently have selected. You can see I've got a main branch here. Depending on the age of the project, some older projects you may find the main branch referred to as the trunk or the master branch. Main is the current term that you'll generally use for most new projects, and Git should do that for you automatically. We then have the option, as we commit more and make more changes, of actually branching off that. So we actually have the ability to make changes without affecting the actual branch that we are currently in. And I'll give a demo of that in a second when we look at some merging stuff too. So where are we at the moment? We've actually got a version of the project that we just had open there in Unity. And as far as Unity is concerned, nothing's changed. Everything's still there, ready to go. I can still run the game and everything's exactly the same. Except now we have that committed to a local repository. So this repository still only exists on our local machine. So if we actually go in here, mean, the Git folder now will be starting to have some stuff in it. It's 138, 39 meg, because it's now tracking all of the changes that we just told it about in that first commit. Having that on your local machine is great, but obviously it would be even more handy to have those changes stored somewhere in the cloud so other people can access them. We've got kind of like a backup in place there. As I said, please don't think of source control as backup, still have a backup solution. And obviously, if we had, like a laptop or a second computer we wanted to work on, it would be a really convenient way for us to clone it and sort of get it in there. So what we're going to do, what we would generally do next, is we would jump over to something like GitLab, and we would actually set up a remote repository for the project. I've done this just a little bit earlier. Basically, the only real thing to note there as you go through it, this can all be set up on a private GitLab account. This we won't need any like sort of paid versions to do any of the stuff we're showing here today, and would generally work the same if you were using again like GitHub, Bitbucket. So any of those sort of ones will generally do the same stuff here. The only setting here that I generally point out, GitLab will give us the option to initialize a project with a README file, which will actually create a main branch and commit just a template README file there for you automatically. Because we've already created a local repository, it's generally just easier to leave that, to untick that, and just basically say, hey, we've already got the repo, we just want a completely blank repo, and commit it. And once we do that, let me just find the right window, this one here, we would end up with something looking a little bit like this. So this is just as I said, just the empty Git demo repository that we just set up. It's got all the commands here for how we would actually connect to that if we were using command line. We're gonna just keep using fork because fork's pretty awesome. We're actually just gonna go up here and just literally copy that. Or would usually have it here if you go like clone with HTTPS, we can just copy that there as well. Jump back to fork. Now, so we've obviously got our local repository, so we want to set up a remote repository. Easy way to do that is where remotes is over here, just right click and go add new remote. You can actually see there that fork realized that I had copied a URL, so it's pasted that in there automatically. As I said, we'll call it origin by default, but you could rename that to whatever you would like. We'll just keep it as origin like that. If you hadn't used, say, GitHub or GitLab before, when you hit test connection, it would actually bring up, like, basically would prompt you through how to actually authenticate and connect your account to that. Obviously, I've done that there. Again, all of your cloud-based solutions will have some really awesome documentation around doing that, so we're not going to go into that per se. And again, if you're part of a studio, they will generally have their own documentation and processes for how you would do that. Cool, so we're going to add a remote. Done. So you might think at this point in time, oh great, we've connected to the remote, so now our project's going to be in the cloud. So let's have a look. If I go back to here and I refresh, oh, the repository is still empty. So why is that? What's happened here? Well, we've committed to the main branch. We've had this particular commit here on our local repository. But if you remember before, we were talking about push, pull, and fetch. What we haven't done yet is actually told it that we want to push this branch to the remote. So the way we can do that, I mean, there's actually a push button right there. If you just right click on main and go into main here, you'll actually see the option here to push main to origin, which is really handy. So I'm going to click that. It's going to pop up and go, hey, like, would you like to push your main branch to a branch called main on origin? So basically, do you want to have the same name? Create a tracking reference. Yep. Tags are a handy option if you want to add like kind of like little post-it notes onto specific commits. But yeah, I haven't done that here obviously, but you could do like push all tags, make sure they get pushed up as well. So we'll just go push. One thing I'll quickly show that when it pops back up there again as well. There was an option there to force push. Be careful with what are called destructive operations. Generally, anything that has the word force in it is a destructive operation. What that means is that normally, if you try to push something for a particular reason you can't do that, it's not a valid operation. Git will just fail and will show you an error message. Force push, or rebasing is technically a destructive operation as well. Is basically saying, hey, I know you're telling me I can't do this, but we're doing it. Um, so to give you an example of what could happen there, let's say use the example again where you were off on holidays for a week, and you come back, make a change, and you force push on a branch. What you are actually potentially about to do is delete or remove all of the commits that everyone else has made since the last point that you had in the project, potentially losing, in this case, a week of work for every other team member. So yeah, just be careful if you're doing force operations or, again, destructive operations. By default, GUIs like fork won't let you do it, at least not without throwing a warning or an error message up there on the screen for you. So it's definitely just to be aware of. Other commands just to be careful with are things like git reset or git checkout, which can basically remove any local changes that you have. So basically, if you are going to do one of those commands, just make sure you have stashed or committed everything you have changed locally. And yeah, there's just a bunch of other commits just to be careful of. But again, as I said, most of them will have the word force in them, and by default, fork won't let you do them unless you tell it that's what you're actually trying to do. Cool. All right, so we have a look now. We can see in our history just here that we connected to. We uploaded LFS objects, which is great. We committed some files. So now if we jump back across to our remote repository and I refresh this now we can see something. So if we actually have a look at commits, we can see this is actually starting to look pretty similar to what we had in fork. We can see the commit we just made. We can see it was made by myself 7 minutes ago. And we can actually see that they're like all the files that actually were changed. So 701 files were changed in that particular commit. Awesome. So now we actually are at a point where we have a remote version of our project. Someone, in theory, actually we can show that actually if we go back to project info. Yeah. We went clone with HTTPS. So if we had, say, another team member or someone you wanted to collaborate with on this particular project, and they had like fork and everything set up on their system, what they would be able to do is actually go in here and go clone. And basically, it's pasted the repository in here. They can choose where they want to save it on their computer. And when they hit clone, it would basically just pull in a completely fresh copy of that project for them. So as I said, great if you want to say work between a desktop and a laptop computer, or if you are collaborating with as part of a team. That's basically everything there for someone else to be able to work in that particular project itself. All right, so we've shown a commit, which is basically committing like the whole project. Let's go in and make a change. Let's have a look what a specific commit might look like here. So let's jump back across into our project. And again, as far as Unity is concerned, nothing's really changed. Everything's just being handled by Git in the background. Unity does have its own sort of collaboration tool that has their own sort of source control built in. It's not a bad option, although I do believe they're in the process of phasing it out for plastic SCM, which is just another source control option. If you like using their tools, awesome. Like I said, using some form of source control is better than not using any source control. But in this particular instance, like I said, Git's just what I generally find is quite popular. So let's say, for example, that I've committed this project, and my first task on this project is we want to make the character jump higher. So we're going to jump into the scripts. We're going to look at like the character controller, and we're going to this is going to be some very rough code in here. This isn't something that is probably going to be production ready, but I just want to make some changes just so we can see what it actually looks like in Git. So let me just open this up in Writer. Cool. And let's have a look at update jump. That's where we add our force by the looks of it for the jump on an up vector. Yeah, cool. Okay. So we're just going to be pretty rough, and we're just going to literally we're going to times that by 10. So we're going to jump, and that jump is going to be 10 times stronger than our jump was before. So we can go back to Unity. We can have a look at how that looks. Where's my Unity? Oh, there it is. So let's jump in. Let's see what a 10x jump looks like. Cool. So we jump. Maybe a little bit high, but you know what? this was the task we were given. This is what our designers asked for. They asked for the character to jump 10 times more. So that's what we're going to go with. So what we want to do now is we want to go, okay, so our designer has cloned the project, and we want to show them like, hey, I've made the changes you want. Would you like to have a look yourself and maybe make some changes, or at least see how it feels and how it looks? So let's pretend that that's what we're doing, and let's do that. So we can see here now in fork, we can see one local change, and we can actually see here that we know it's in the character controller because we just did it, and you can literally see the line marked in red, which is the line that is being removed, or basically being marked as having been removed, and the green line being the new one that's been added. You can see they're both line number 178 here, so really handy. And it's even gone so far as to highlight the specific change in the line that we've made there, which is really handy. A really cool thing that a tool like Fork actually can do for us as well. So let's say, I'm just going to jump quickly back to code, and let's maybe pretend that when we land, we don't want to play any sound anymore. So we're just going to comment out that line there as well. Cool. And you can see here it's seen that change there as well. Now, as I'm working in a file, because remember, our designers only asked us specifically about that jump. So we've made this change. We're just going to keep that there for now. We're not going to worry about staging that just yet. We can actually just go in and stage this one specific change if we wanted to, like that as well. And you can see here, we've now still unstaged. We've got that audio change, but now in our staged file here, we've got that actual jump change, which is really handy because we might be maybe on a Zoom call with our designers at the moment, and they're like, oh no, yeah, we still want the change for the sound for the audio for landing, so we're just going to discard that change there, like that. And if I actually go back to Writer now, you can see that that line is back, it's uncommented, because we've just basically reverted that change that we're in the process of making. So very, very handy as we're sort of being able to see exactly what has changed in any particular file. So we've made the change thereafter, but because we don't want this change to be committed, so our main branch is generally what we would consider to be, hey, this is stuff that we are ready to ship out in a production build. Like this is what the players are going to see. And we're not quite sure yet because we're still testing out. Designers want to have a look. They might tweak it themselves a little bit. So what we're actually going to do now is we're actually going to make a new branch. We're going to hit the little branch button up the top here, and we're going to say this is it's a new feature, and we're going to call it jump height with a little camel case there like that. And we're going to check it out after creating it there as well. So you can see here. All right. So what's actually happened here? We've still got the main branch, but now we've created another branch at the same point that we were, now called feature jump height. So now if I go character now jumps, I forgot to type, a bit dangerous, 10x as high. And we can just commit this file, but we can actually see if we hit the little arrow, we can actually commit and push, which basically is taking the two steps we did separately before, where we committed it to our local repository, then we pushed it to our remote repository, and we're just going to do them both together. So we're just going to commit and push here. And we'll see it doing its thing up the top here. Writing, and done. And again, here's how quick it is. If I come straight back here, refresh, and if I change from the main branch over to feature jump height, I can see there was a change in the assets folder. I mean, I know where it is. It's that one just there. If I click on that, it'll actually take me specifically to that commit, and I can see exactly what was changed. So again, great for a team to be able to quickly see what's changing within the project. If I jump back to fork now, we can actually see what's happening here. So we still have main, but now we've got our new jump height branch, which now has that change where the character is going to jump 10 times as high. And we're there now. So if I go back to writer, we can see that we're jumping 10 times as high. While our designers are going off and they're going to have a look at that now, I've been asked to do some other work. I've been asked, oh, we need to change some of the things in the scene. So, okay, cool. I don't want to do it here because I don't want to affect what the designers are doing. So I'm actually going to jump back to our main branch here, like that. You can see it's got a little tick there to show where we're currently at, and a little GitLab symbol here showing that is at where that's currently the head commit on the remote repository as well. So if we come back now to into writer, that change has now disappeared because we never committed this change into the main branch. We committed it into its own separate branch for the designers to look at, and now we're free to go about and work on something else, which is really cool. But let's say, all right, so let's go in and let's make some changes to the scene. Let's go into the environment, the background. Maybe we're going to turn off the sky. We're going to grab these things and we're going to move them to the foreground. Let's see, maybe this one shouldn't actually be a prefab anymore, so let's unpack it completely. That sprite shape, we're just going to disable the controller. The grass, what do we got here? Let's edit the spline on that and make it like that. I'm literally just trying to make changes here that just could look similar to what you might see if someone was actually editing a scene. But just, yeah, basically trying to just move things around a little bit. Maybe change. Oh, let's make that a kinematic just for fun. Why not? Cool. So we've just made a bunch of changes within the scene file itself. So let's go back and see what fork has to say about that. You can see here, local changes, and it's in the scene file. And you can actually see all the different things that have changed. There's quite a bit of them here because we've moved a fair few things around, which is basically how the changes that Unity has made to that particular scene file. So cool. We're asked to make those changes. Now again, we don't want to commit it to main because we want to give someone else the opportunity to inspect our work and see what's going on. So we're going to commit this to a new branch, and we call this feature scene update, like that. Changes as requested in Jira ticket 1234 for main scene. And we'll commit and we'll push that there as well. We're pushing, and we're done. Cool. So, and here's where source control starts getting really cool. So you can see here, obviously we've now got, a couple of different branches. Our main branch still is the project as it was with no changes on it. So this might be the version that we've released to the public, for example. And we can see here that our designers are looking at the jump height, and we can see that, maybe someone else is reviewing our ticket. Oh, I spelled that wrong. For some changes to the main scene. So our designers have just come back to us and they're like, yep, we love the jump height. So we're happy with that. We're happy for you to merge that into main for that to go out to the players. Cool. Normally we'll do this through, there's a merge, like something called a merge request. I'm just going to sort of skip over that for now. But again, that would be if you want us to do a Git 102 talk, that's probably something we can throw in there. So what we actually want to do now is we want to go back to our main scene. We want to grab this jump height branch, grab it here, and we want to merge it into main. And what that's actually telling us to do, and we'll say fast forward. Oh, no, we'll actually we'll create a merge commit for clarity. So what this is actually doing now is it's saying, hey, grab all the changes that have happened in this particular branch and bring them across into main. Now, in this particular case, there was only the one, which again was that times 10 change on the jump. But it sort of brought that across and it's updated that within main, but only on our local one. You can see here that origin main is still where it was before, because again, we haven't pushed the change yet. So we're here, we've got the tick mark, so we can push this, and now main is going to get updated. So now anyone grabbing the project, if they were grabbing it and were looking at the main branch from the remote repository, they would now see the changes where we can now jump 10 times as high, which is pretty cool. So while this has all been happening, the art director has come back to us going, hey, we're not happy with the lighting. We need to make some changes to the lights in this level now. Okay, cool. So what we're going to do, we're in main. We don't want to touch the scene update branch because they're still just looking at the geometry changes that we made to that scene. We're going to jump into main and we'll go back to Unity. If I can find my Unity window, there it is. We just need to reload our scene because we did have the one open from the other branch, so we just need to tell it to reload that there. So important to note that times 10 jump change. We're in main, but that change has now been applied, so we've got the times 10 for the jump there, which is good. But we're going to go in, we're going to grab the lights. Please do not think this is what you should do as a game developer. I'm just literally trying to do things so that it will make some changes. That that, that could be gradient, that, uh, this one, edit the shape like that. We're going through and maybe we'll turn this one off, maybe this one gets deleted. Sunspots, maybe we're gonna duplicate those a couple of times and we'll just move them a little bit. Cool. So we've just made the lighting changes that we've been asked to do. Awesome. So again, we jump back to fork. We have a look, and again, we've got more changes here in main. We made a lot of changes. So fork is literally just saying, hey, I don't want to show this. We can make it do it, but it's going to be pretty slow. And yeah, you can see that we made a lot of changes here to this particular file. Cool. We'll stage it. Again, we want to put this in a separate branch so people can look at it first. So we're going to go branch. We're going to call this feature lighting update. Like that. Updated the scene lighting in main. And we'll commit and we'll push that as well. So we can see here, we've now got a world where different people can review the work we've done here. We can always go back and see what's happened in main. We can even go right back if we wanted to. If we actually just right click on this particular commit here, we can actually check out this commit if we want to. We're going to get what's called a detached head because we're not actually at the most recent commit in any particular branch. But we've gone right back to here. And again, if we go back to our Git, we can see the jump isn't there anymore. And if we go back to Unity, we'll need to reload the scene, and we're actually going to be right back at the very start. So literally everything we've just done in the past 20 minutes or so has just been reverted right back to how it was when we very first started today, which is cool. But, okay, we're going to get some work done here. So let's have a look back at fork. Now, the art director who's looking at the scene update, they've just heard that we did the lighting update, like, oh, well, we probably need to see that in this particular branch so we can see what's going on. Yeah, cool, makes sense. So let's go into the scene update branch. And like we did before, we'll grab the lighting update branch and we're going to merge that in. So we're going to say, hey, grab all the changes in this branch, bring it over to the branch that I'm currently in. We're going to go merge. And this is what I was hoping would happen. So now we have this merge will require manual conflict resolution. So because we've made changes in different branches to the same file, the problem is Git by itself is gone, hey, I don't know what you want me to do with this file. I can see changes like overlapping on top of each other, so I'm not sure what you want me to do. So really great thing with Unity is specifically for any of these merge conflicts that will occur within scene files or within prefab files, we actually have what's called the Unity YAML tool. So I'm going to go merge here, and it'll go, hey, merge failed. You need to fix the conflicts for me and then recommit the result. Cool. Okay. So it's basically saying, hey, I don't know what to do with the changes you've made to this main file. I saw that question and wherever that just popped up, and I'll answer it in one tick. So you can see here it's saying, hey, so I can see that this file was changed in scene update. I can see it was changed in lighting update. What do you want me to do? So sometimes the answer might just literally be as simple as, hey, ignore the updates from scene update, just grab the version of the file that's here, and that's the one we want to work with. But in this case, we actually want to take the changes in both and sort of merge them together. So what we can actually do is if you go into your preferences for fork, and I'll link the documentation for this as well. But yeah, Unity has documentation on how to use this tool across most popular Git GUIs. We have what's called the Unity YAML merge. Now, it will be within your Unity editor folder, whichever version you're working in editor tools data, and the file just lives there. And the arguments is this line just here, which again, we'll throw this all in our Discord for everyone as well. Sneaky way to make you join our Discord, which is really awesome. You get to see photos of my cats and some of Anne's awesome art in there, which is really cool. So we've basically told Git, hey, if you're having an issue merging, here's this external tool that might be able to help you out. So we've told fork about it. We're just going to hit merge an external merger. It's going to do its thing and go, hey, done. Now we can actually stage that file, which has been fixed. And we can actually see here that because lighting update was further ahead in the main branch, we've actually grabbed this update here as well, because we're grabbing everything that's changed in lighting update compared to jump height. So you can see here, we've actually also grabbed the character controller changes that we made back there as well. And we're going to commit and push these changes now. So now we have an updated scene update branch with all of the changes correctly merged in that we have in the lighting update branch. So let's jump back to Unity and have a quick look. Again, Unity will need to reload the scene for this one. Reload. And we can see here, like we saw, we changed that from being a prefab, we moved some of the environment stuff around. So it's basically taken the changes we've made in both of those separate scene files and thrown them together. The YAML tool will not always work. As you are getting into more complex scenes, more complex prefabs, it's less likely to be successful. But yeah, definitely will work in a lot of simple cases such as this. But yeah, just keep that in mind. It's not a silver bullet. It won't always work. But yeah, definitely will work. 90% of the 90% of the time it works every time. That sounds about right. Cool. Okay, I saw a question just come through from Anne just before. You're gonna have to let me know where you sent that question, Anne, because I can't see it.
You've done enough work to commit it, I guess.
Okay. Yeah. Cool. That's a good question. So, generally speaking, and different developers will have different theories around this in terms of how much they'll put into a single commit. You generally want to commit things together if it makes logical sense for a group of work that you've been doing. If there's ever a chance you may want to go back to how the project looks at that specific point in time. So say as like I guess like a generic example, let's say we're making a game and there's going to be 100 enemies running out and throwing, I don't know, axes at us, for example. I would make a commit after I've created the enemy prefab. I would probably have another commit after I've written whatever script I'm using to instantiate the 100 enemies. And then maybe another one when I've written like some AI stuff to get them to move around and how they're actually being controlled. As a general rule of thumb, having more commits is better than having less commits, because it makes it much easier for yourself or anyone else working on the project with you to have the ability to go back and have a look at specifically something that you were working on, or see those sort of individual changes that you've made. If you've got so using that same example, if you just had all the work you had done for the enemies in one like single commit, if there's something within that doesn't make sense, or it might represent several days of work, it's very hard to sort of break that down and see the thought process and see what was actually happening there. Whereas if I can see 10 commits of creating the enemy, creating the spawner, creating the AI and stuff like that, it makes it much easier for me to go back through and even for testing purposes. Like let's say for example there's a bug where the enemies will only attack once. I can go back, all right, I'll go back and have a look at the very first commit. Was the bug there? No. Go look at the next commit. Was the bug there? Yes. Okay, so now I know whatever has broken that particular part of our like enemy prefab in this case happened in this specific commit. It makes it super easy to be able to go back and try to figure out exactly where changes were actually being made, or where potentially like a bug was introduced, or things like that. So yeah, generally speaking, commit more is usually not a bad thing, because keep in mind as well that when you actually merge, say you have a working branch with say 50 commits, once you merge that into your main branch or dev branch or testing or whatever branch you have, sort of your main trunk of the project, there's nothing stopping you from, you can do what's called squashing, which basically is taking a bunch of commits and packing them down into one. Or you can even just theoretically later on in the life of the project you might just delete that branch completely. But yeah, as a general rule of thumb, I would always rather see more commits as opposed to less. It just makes it so much easier for other people to see what's happening, and for yourself to go back and bug fix and work with the code that you've written. Awesome. Does anyone else in chat have any other questions? Otherwise, that's pretty much everything I wanted to sort of touch on today. So just as like a bit of a recap, we've looked at how to use source control to work within your own local repository, how to take that repository and store it in the cloud using, in this case, GitLab, but using any other form of cloud-based source control providers. From there, we've looked at how we might, work, creating different branches as we're working within a project, how we can see those specific commits as we make changes, and then what can happen if we have like a merge conflict and how we can use like the YAML tool to sort of merge them together. Do I have any slides after this? I did. Oh, there you go. There's just a nice sort of demonstration of like Git workflow there, which hopefully is helpful. But that's pretty much it. So as I said, hopefully this was a valuable sort of primer on source control. If you do have any questions, obviously please jump into our Discord. We have like an Ask a Dev channel where our team's in there and very happy to answer sort of questions. Yeah, hopefully this was valuable, and yeah, we'll catch you all at our next video. I don't, Anne, are we telling people what the next video is going to be yet, or not yet?
Yeah.
I can say?
Uh, maybe not,
Okay.
because like it's still a work in progress. But
Yeah, okay.
yeah.
Oh, if you'd like to make sure you catch all of our events like this that we host, again, jump in our Discord, and we'll announce the next one very soon. Cool. Have a great day, everyone, and we'll catch you next time.